Have you ever looked at a university course list and just seen, a jumble of subjects? Well, what if I told you that behind that list, there's actually a hidden architecture, a deliberate blueprint for building an expert from the ground up? Today, we're going to pull back the curtain on that very design.
So is it just a list or is it a blueprint? To find out, we're going to break down the M.Tech program in Project Engineering and Management from Jharkhand University of Technology. And we're not just reading the syllabus here, we are reverse engineering the very architecture they use to build a master in the field. Okay, first things first, you have to get your head around the core challenge. An advanced degree isn't just about cramming more information into someone's brain. No, it's about engineering a transformation, literally turning a student with potential into a professional with true mastery. And that kind of change, it just doesn't happen by accident. It requires a really deliberate plan. So how do they do it? Well, this curriculum reveals a kind of secret blueprint, one that's built on some really powerful learning theories. Let's start with the first principle, which is an absolute classic rule for getting things done effectively.
It's the 80-20 rule. You know the one. The designers of this program, they didn't try to make every single course equally important. Instead, they used the Pareto principle. They figured out that critical 20% of subject areas that would deliver 80% of the foundational skills an expert truly needs out in the field.
And when they boiled it all down, it came to just 5. That's it. Out of all the potential courses, these 5 core areas are the high-impact zones. Think of them like the structural pillars holding up the entire degree. And here they are. It all starts with the fundamentals, the principles of project management. Then it builds in crucial skills like financial planning. After that, it equips the student for research methodology, and it all culminates in that final dissertation. See? Together, these 5 pillars create a rock-solid foundation for everything else.
Now, the second part of this blueprint is how they structure the learning journey itself. And this is just brilliant. They use Bloom's taxonomy. The whole idea is to move students up a ladder, right? You start with the simple stuff, like recalling basic facts, and you progressively climb towards the highest level of learning, which is creating brand new, original work.
So how does this whole ladder idea actually play out over time? Well, the entire 2-year program is engineered to guide students up that ladder, with each semester representing a new stage of their development. It's not a random collection of classes, it's a very carefully sequenced ascent. And you can see this progression mapped out so clearly. Semester 1 is all about the foundation. Semester 2, application. Semester 3 is where the synthesis begins. And it all leads to that final semester, the demonstration of mastery. This actually reflects a core educational idea called the law of progressive development, where each stage builds logically on the one that came before it.
So in that first semester, students are right at the bottom of Bloom's ladder. They're just focused on remembering and understanding. They take foundational courses like Principles of Project Management and Production and Operations Management to build a really solid conceptual framework for everything that's going to follow. Then, in semester 2, they start climbing. They move up to application and analysis. This is where they take all that foundational knowledge and start using it with courses in financial planning, quantitative techniques, and, this is crucial, a mini project to test their skills out in a controlled setting.
Semester 3 is a really big leap. The focus shifts to evaluation and the beginnings of creation. Students dive deep into research methodology, and they have to go do a mandatory real-world internship. This is the point where they stop just learning what's already known and start to create their own original insights. And finally, semester 4. This is the top of the ladder, pure creation. The entire semester is dedicated to one thing, the major project and dissertation. This is the capstone, the grand finale, where students have to produce a substantial piece of original work, making their own unique contribution to the field of project engineering.
Of course, a blueprint on paper is one thing, but a master engineer has to be able to perform in the real world, right? This is where the curriculum really stress tests the theory, building in these mechanisms to bridge the gap between the classroom and the actual job site.
You see, the program is designed with this constant feedback loop between the classroom and the real world. Core theories and models that you learn in a lecture get immediately put to the test through software labs, complex decision-making scenarios, and of course, that vital internship. And don't think of these labs as just some optional add-ons. They are absolutely core to the design. These are integrated workshops where students get their hands on industry-standard tools like MS Project and literally pressure test their theoretical understanding in a practical, hands-on environment.
And the ultimate test, the final validation, it's that 8-week research internship. As the curriculum itself says, this provides the ultimate validation of learning. It's the final bridge, making sure that everything learned in the university is actually relevant and applicable in a real professional setting.
But a great educational design can't just work for today. It has to anticipate the needs of tomorrow. A rigid curriculum can become obsolete so fast. So how does this program stay relevant? Well, the answer lies in its really strategic use of electives.
This is so smart. This is how the program future-proofs its graduates. It lets students customize their learning with these elective clusters in emerging, high-impact areas, everything from AI and Industry 5.0 to sustainability to agile innovation. This literally empowers them to build a degree that's ready for the challenges of tomorrow.
So, what's the big takeaway here? You know, whether you're a student, an educator, or just someone who loves to learn, this shows that the most effective learning experiences are never an accident. They are systems, deliberately and carefully architected to guide a person from just having knowledge to having true capability.
Which leaves us with one last, kind of provocative question. Seeing how a master's degree can be architected just like this, you have to wonder, is this kind of deliberate, psychologically driven design the future of all learning, both inside the classroom and out in the real world?